This is Geometry, Chapter 0, Section 3, in which we will be studying simple probability. First, we need to know what probability is. It's the ratio of number of successful trials, whatever we've defined to be success in this particular problem, to the total number of trials. Another word for trials is possibilities or outcomes. Number of successful outcomes to the total number of outcomes that are out there. So suppose I take a standard die, like you would find playing Yahtzee or Monopoly or some such, and I roll that one die. I want to know the probability of rolling an odd number. Well, I need to know how many odd numbers there are. 1, 3, and 5. Those are the only odd numbers on a standard die. How many possible outcomes are there? There are 6 of them. 1, 2, 3, 4, 5, and 6. So my probability is 3 over 6, which reduces to 1/2. You always want to reduce these fractions if you can. Or if you're a decimal fan, you could report it as 0.5, 0.50. If you're a percent fan and you want to go to the extra trouble to make it a percent, that would be, of course, 50%. And unless the problem specifies otherwise, I'll take any of the three. If it says give me a percent, you have to give me a percent. If it says a fraction, you have to do a fraction. But if they don't say, any of the three that are correct are good for me. Okay. Let's suppose we have a bag with 4 red marbles, 3 greens, 6 blues, and 2 yellows. And I'm going to hold the bag, I would say above your heads, but some of you that would be kind of impossible for me since you're taller than I am. But I'm going to hold the bag in such a way that you can't see what you're grabbing. And I'm going to ask you to reach in the bag and pick out a marble. I want to know what's the probability that it is not yellow. Well, I need to know how many not yellow marbles there are. All of the reds, greens, and blues are not yellow, so there's 13 not yellow marbles. There are 15 total marbles in the bag, so the probability of not getting yellow would be 13 out of 15. I left it as a fraction. If you want to convert it to a decimal, knock yourself out. Not literally, please. Paperwork's a nightmare. It'll be somewhere around 0.91. Suppose I want to know the probability of getting blue or green. If I get a blue one or if I get a green one, that's a win. That's a successful trial. So we need to know how many blues or greens are there. There's 3 green, there's 6 blues, so there's a total of 9 good marbles, successful marbles, winning marbles, whatever you want to think about it as, out of the 15 total marbles there are. So the probability would be 9 out of 15, which reduces to 3/5. And again, if you want to convert it, go for it. It's 0.6 or 60%. Now, what we've been finding so far is what we call theoretical probability. It's based on what could happen. But if you roll a regular die 600 times, you probably won't get 100 ones, 100 twos, 100 threes. It could happen. In theory, it should happen, but it usually doesn't happen that way. The other kind of probability is called experimental probability. It's based on what actually happened when you did things. So let's consider this situation. We got out a very funky 8-sided die. Yes, they make them. They also make 10-side, 12-side, 20-side, 26-side, I think I've seen. All kinds of crazy dice. even make a 4-sided. But this one was an 8-sided die. And they actually rolled the die a certain number of times. We'll have to figure that out in a minute. And they recorded what they got. So for 1, it came up twice. 2 came up 3 times, and so forth. I want to know the probability of not getting a 4. Well, there are 19 if you count those all up. There are 19 of them that are not 4 out of the 25 total rolls. So that probability would be 19 over 25. The probability of getting a 3 or a 7, there's 3 3s, and there was 1 7, so it's 4 out of 25. And then the last thing I'm going to throw at you here, I'm going to ask you to pause the video once again and try this problem. Find the probability of getting a prime number. Remember, a prime number is a number that's only divided by 1 and itself. And here's a hint, 1 is not considered a prime number. So pause the video, try it, come back, and we'll check your answer. So in this grouping, the only prime numbers are 2, 3, 5, and 7. We got 3 there, 3 there, 4 there, and 1 there, for a total of 11 out of 25 were prime numbers. And as always, if you had questions, hopefully you wrote those down on your note sheet and bring those with you, and we'll see you in class.